Hello everyone, this is Dr. Padmanjali Nehagargi presenting a video lecture on CC Lab on the operator precedence parser for 6M TEB division as well as few batches of A division. Let's begin the session. Operator precedence parser, which is also known as the bottom-up parser, and this is the program for sixth program of the CC Lab for operator precedence parser. As operator precedence parser is also known as the bottom-up parser, a grammar that is used to define the mathematical operator is called an operator grammar or the operator precedence grammar. Such a grammar have either no productions or have null production, or it can also have, or it may not have, the two non-terminal, which are nothing but the two adjacent non-terminals in its right hand side. That means a production has either an empty right-handed side, that is using the epsilon, or a grammar or the production that has two adjacent non-terminals in its right hand side. For this such a production, how it can be, I'll be telling in the further next slide how such a productions can be. That means any productions of the grammar that have a complete grammar means using the operators. Such the productions which are using the operators are said to be as the operator grammar, and there are some examples like S giving SAS, or it can also give an identifier A. Such a production or the grammar is also said to be as a non-operator grammar because such a production or such a grammar has not got any operator in this grammar. This is such a grammar or the productions has got the operators in between the variables, and this such a non-operator grammar can also be yielded to an operator grammar by further substitutions of this variable or the non-terminal variable S giving S, and with the combination of the terminals and non-terminals may with the combinant that which yields to the terminals finally. And here this S gives with the terminal A with some few recursive combinations of the variable by substituting S with either A and further the non-terminal A for the substituting by the by the two set of productions, that is with terminal and non-terminal, and again with the terminal, and or it can yield to B, or finally recursively it can be called by B. So such substitutions can also be given or can also yield to the grammar which was of a operator grammar. Then how a grammar a grammar should not have any null productions, or again it should not have any it should not have any two adjacent non-terminals in its right hand side of the productions. So how a grammar can be, in this slide we can see, and such a grammar which can be used for solving the mathematical operator, that is called as an operator precedence grammar. I think you have come to know what is, what type of the grammar should be. Means a grammar should not be should not have any mistakes. That is, in its production it should be a complete grammar by having the operator precedence, or it can also be complete grammar by having the terminals with the combination of non-terminals. I hope how a grammar should be you have understood here. Now moving on to the next slide to show that how a operator precedence grammar can be solved. And this concept is used for the program to implement the operator precedence parser using, such a concept is said to be as the bottom-up parser. As now in the first slide I have shown you that what is an operator precedence parser, and that operator precedence parser, now we have come to know that it is an bottom-up parser that interprets an operator grammar, an operator grammar here, an operator grammar. This parser is only used for operator grammar, and only in this concept, that is operator precedence, a grammar can be an ambiguous grammar. An ambiguous grammar are not allowed in any of the parser except in this operator precedence parser. There are two methods for solving the operator precedence grammar or the operator precedence parser. One is the associativity and the precedence of operator. The associativity is not for the lab session, and the precedence of operator with the associativity will come to know in this operator precedence parser. Let's move on to the concept of the operator precedence parser using the precedence of operator, the second method. Using the second method, that is the operator precedence parser. The operator precedence parser, here it uses the relation table. Before going to this relation table, what it is and how does it can be constructed such a relation table using the grammar, as we have seen in the first slide. I was taking the first example, like E yields with the three combination of the productions. That is, the first expression is the addition, and the second expression is of the multiplication, and the third production is of the only one combination of identifier. Only one combination of identifier. In operator precedence parser, which relies on the three precedence relations, that is less than, greater than, or equal to, not or, less than, greater than, and equal to. How it can be precedence of less than, and how it can be precedence of greater than, and how it can be precedence of equal to on an operator, and that operator precedence can be an identifier or operators, Like suppose A is less than B, A is less than B. We all know the very long backdated data structure concept. Like A is less than B means, this means here what? It yields, A yields precedence to B, and if A is greater than B, this means it takes the precedence over B, and A is equal to B in the sense A is as same as having the equal precedence of B. That means here the operator and the operands. How is the precedence between the operator and operands? Like say for example, the below the table, we can see here I have a grammar here, the way the cursor is moving, I have a grammar, the same old example which I have taken in the first slide. E yields, let me go with the cursor, E yields, or E gives the expression or the production of addition, and the second production which is giving the multiplication, and the third production is giving the directly the identifier. So here how we need to solve, how exactly is called the operator precedence. We can solve this by two methods, as I said. One is the associativity and the another one is the precedence of operator, which is using the relations table, the precedence of operator using the relation table, and this table shows using the relationals between the operands, between operand and operators. Like the production, if the production is having, identifier to identifier, in the sense it is already a successful expression. So if the production, here let me tell you one more thing clear. The associativity among this is identifier is having more precedence than the identifier is having most higher precedence, because it is already solved, because the ultimate goal here is using the parse tree to reach to the identifiers only. So using the bottom up parser, so how we reach that, or how we yield and grammar which is of having the finally the identifiers, means the terminals, reaching to the terminal. So it already itself is having the highest precedence whenever a direct parse is reaching to the identifier. So this next precedence is for the multiplication, and the next precedence is for the plus, and lastly the dollar sign, the dollar operator, and here it is as per the grammar plus, and as per the given grammar, that is the plus and the multiplication. Here is the plus and here is the multiplication. So what is the order here in the, in the column wise what we are taking, the same order should also be taken in the row wise. So identifier which is a blank, the first cell which is of the blank, which means that already it is a successful parse. So here identifier is having a greater or the highest precedence as compared to the plus, so it is a greater relation. If there is a comparative between the identifier and the operator means, and what is that operator? That operator is plus. So there is a comparison between the plus and there is a comparison between the identifier and the plus. So as I said you that identifier is the highest precedence, so it is 1, and among the operators the multiplication is the second precedence priority, and the third is plus operator, and the last one is the dollar sign. This looks like dollar sign, not looks, it's a dollar sign or the dollar operator in between. It can exist in between the identifiers. So here, as I said, the identifier it itself is having the highest precedence, so it is a already successful parsed operator, parsed identifier. Now the comparison should go between the identifier and the plus. So here we are doing the left associative comparisons. I'm following from left to the rest of the columns, the every row with every column. So if the identifier, if the precedence is checked between, if the precedence is checked between the identifier and the plus, so naturally this, the left hand side of every rows are nothing but A's, and every uh, fields of the columns are nothing but the B's. We are rolling over from A to these we are rolling over from A, every rows to every column head, every rows to every column head, to show the relationship between the identifiers and the operators among the productions of the given grammar. So here identifier with plus, identifier is compared with the plus operator. So an identifier E naturally it gives to E. E is compared with plus. So what is the precedence among this? So the precedence is given to identifier, that is greater than. And identifier with the operator, of course naturally, as I said, identifiers are given as the most highest precedence than whatever may be the operator. So naturally it is a greater, identifier is greater than multiplication, so it is greater relation, it is having the greater relations. First it is solved. The next identifier is compared with the dollar. So the identifier is compared with the dollar operator, means naturally the dollar is having the least precedence among all the operators, among whatever may be the operators. So actually naturally the identifier is yielding or gives the greater relation on the dollar B. Next, going to the next row, that is the plus operator. If E, if not E, if the plus among the plus and the identifier, the plus is the operator, the addition is the operator plus, and it is compared between the next identifier, that is E, then naturally B takes the highest precedence on plus, so A is having less precedence on this identifier. As I said, identifiers are more given precedence, are more given higher precedence. So here plus is having less precedence as compared to the identifier, and plus plus here, how is the plus precedence? As we are moving from left to right, so the associative follows from left to right, so plus associative have the higher precedence than the right side, than the right hand side, than the movement of the right hand side of the parse tree. So plus is having the highest precedence. Next, plus with plus, the operator plus is compared with the star. So plus is having the less comparative associative as compared to the star, so star is having more precedence. So here naturally moving from left to right, that is plus, there is a comparison between plus and plus and the multiplication, means naturally plus, of course plus is, A takes, or A takes over B that is multiplier. So plus is having less precedence as compared with the star, so it is less relation. So plus with the dollar sign, plus with dollar sign, naturally dollar is having the, naturally the dollar operator is having the less precedence, so plus is taking the higher, takes over the higher precedence on the dollar sign. So here relation is greater sign. Next, naturally, next the third row, that is the third row is the multiplication. Multiplication is having more precedence, sorry, having the second precedence than the identifier, so it is having less precedence. And multiplier with multiplier operator is compared with plus means, so of course plus is having more precedence, so it is greater sign, greater relation. And among the multiplication operator, naturally movement is from the left to right, left associative to right associative, so the left associative is having the greater precedence, so here the relation is greater precedence. And then from multiplier operator, compared between the dollar, of course the dollar is having the less precedence, so here less precedence as compared with the multiplier, so movement is from left to right. So the here again the associative is, sorry, not associative, here is again the priority is given more to the multiplier operator, therefore here relation is greater operator as compared with the dollar sign.